Okay, so in this video we're going to have a look at the product rule for counting. Now the big thing with this topic is it's relatively simple actually to go about actually doing, but the thing with this topic is some of the language as it changes throughout the course of the topic. So we're going to have a look at a few to start with, we're going to have a look at a few in reverse, and we're going to have a look at the differences in language as the sort of topic progresses, just to make sure that you get your full marks on these sorts of questions. But grab a piece of paper, grab a pen, we're going to have a look at a couple of questions, few for you to have a go at, but it's relatively quick and simple for us actually to do the maths behind this, so it's not going to be that long a video. So this one says there are 17 men and 26 women in a choir, and the choir is going to sing at a concert. It says one of the men and one of the women are going to be chosen to sing the first song. Work out the number of different pairs that can be chosen. Now, if we kind of come away from this question for a second, we think about maybe a bit of a simpler idea. If we imagine instead maybe that there are 3 men and that there are 2 women, and we have a look at the different amount of combinations that could happen here. Now, for the sake of making this a bit more simple, let's imagine that we've got man 1, man 2, and man 3, and we've got woman 1 and woman 2. And we kind of imagine this in a little bit of a table. So man 1 at the top, man 2, and man 3. And then we could have woman 1 over here and woman 2 here. And we're going to have a look at the different combinations that we could actually get if we think about the pairings that we could have. So we could have woman 1 paired with man 1, we could have woman 1 paired with man 2, and we could have the woman 1 paired with man 3, giving us 3 different combinations there. Then down below, I've just realised that I've put an M there rather than a W, so let's change that quickly. Yeah, that was supposed to be woman 2. And then down below there, we could have woman 2 also paired with man 1, we could have woman 2 paired with man 2, and we could have woman 2 paired with man 3. There we go, so just a little bit of a visual idea for you, but look, if we count those up, we've got 1, 2, 3, 4, 5, 6. And this sort of logic is going to be applied to all of these questions, because really all we had to do, if we knew we had 3 men and 2 women, we just had to do 3 times 2. Okay, which would give us 6 options. And this sort of logic is going to be applied to a lot of these questions when the numbers are bigger, because obviously what we don't want to do is draw a column of 17 men going down and 26 women going across and have to draw out all of these combinations, when actually you just think, look, every row is going to be, every amount of however many are in that row is just going to be multiplied by however many are in that column. So we're going to apply that logic to a lot of these questions, but there's just a basic understanding of why we're going to do this the way we do and how we can get away with applying a little trick here and not actually have to draw out all these combinations. So coming back to this question, look, all we really care about is the fact there's 17 men and 26 women, and we're going to do an amount of different combinations that can be chosen. So it says work out the number of different pairs that can be chosen. Well, nice and easy then, all we have to do is think, okay, well there's 17 men that can be paired with a potential 26 women. So we're just going to do 17 times 26. There we go, so 17 times 26 is 442. And there we go, there's our final answer, 442 different pairs that can be chosen. So there we go, that is the product rule for counting. I'm going to have a look at some different scenarios, different wording and different sort of elements to this topic. But essentially all it is you take the number of options in the first pick and you multiply it by the amount of options in the second pick, and in that second pick there were 26, and in the first pick there were 17, so we just multiply those together. But let's have a look at a few different types of questions here. Okay, so there is something slightly different in this one. It says a cafe owner sells 10 different types of sandwiches. Hassan buys a different type of sandwich on Monday, on Tuesday and on Wednesday, and in how many ways can he do this? Now this is slightly different, look, because it says he buys a different one, different type of sandwich on each day, but there's 3 days here. So on the first pick, if we imagine we've got our first pick here, okay, we've got 10 different types of sandwiches. Now by the time it gets to that second pick, he no longer has 10 different types of sandwiches because it says he's going to buy a different type of sandwich on each day. So on that next day, it doesn't matter what he buys on the first day, but he'll only have 9 options on the next day. So we're going to do 10 times 9. If it only said 2 days there, our answer would be 90, 10 times 9. So now we're thinking about obviously the third pick, because it's 3 different days. We've got Monday, Tuesday and Wednesday. And obviously if he's picked a sandwich on the first day, he's picked a different one on the second day, on that third day there, he's not going to have 9 anymore, but he's only going to have 8 to choose from, just to make sure he gets a different sandwich on that third day as well. So we've got 10 times 9 times 8, and that gives us a total, I'm just doing these on the calculator, of 720. There we go, so we've got 720 different options, okay? Now obviously the options here, then the language is important. It says how many different ways can he do this for the different type of sandwich each day. Obviously let's imagine on the first day he picks a cheese sandwich, okay, just thinking of a random sandwich here. So if he picks a cheese sandwich on the first day, That would be one option. Obviously, you can't have a cheese sandwich on the second or third day, but if he picked a different type of sandwich on the first day, so not a cheese sandwich, he could actually then get a cheese sandwich on the third day. Okay, just not if he picks it on the first day. So it might be that we've got the similar combinations here. For example, the 3 same type of sandwiches but on different days. So we don't have to worry about that. It's just dependent on what he picks on what day in order for this sort of question here. So we're going to have a look at something slightly different as well. But just thinking about this type of question here, when there's only one option of things to choose from, this one being sandwiches rather than different people, obviously we just need to make sure we reduce that number by 1 if it is going to be a different one on the following day. So just thinking about how many we actually could pick on that second and third day there. Let's have a look at having a go at some of these then. So I've got a couple of questions for you to have a go at. Here they are. Okay, so there's 2 questions here, very similar to the first few that we've just looked at, but obviously just a different scenario here. So have a little go at these 2 questions. Pause the video there and we'll go over the answer in a sec. Right, okay, so this first one says there are 4 starters, 7 mains, and 4 desserts in a restaurant. Work out the total number of ways of choosing a starter, a main, and a dessert. So we've got 3 in here, okay, but it's not similar to that second one. There's 3, but none of these are going to get reduced each time. We've got 4 starters on the first pick. On the second pick for the main, we've got 7 mains, and then we've got 4 desserts. So it's just 4 times 7 times 4. And that's going to give us 112. There we go. So we've got 112 different ways of choosing from this particular menu. There we go, and there's our final answer. Now this next question here, it says there are 52 cards in a deck. Okay, James is going to give 1 to Alice and then 1 to Ben. How many different ways are there of doing this? So on that first option there, he's got 52 different cards that he can give to Alice. By the time he's given 1 to Alice, so one of those cards is gone, and there's only 51 cards left there to give to Ben. So there's going to be 51 options on the second pick. So we just need to do 52 times 51. There we go, making sure we reduce that by 1, and we get 2,652 different ways that Ben can actually do that. There we go, and there's our final answer for that question. Right, let's have a look at this in a little bit of a different way then. Okay, so this question says Jeff is choosing a shrub and a rose tree for his garden. At the garden centre there are 17 different types of shrubs and some rose trees. Okay, so we don't know how many rose trees. Jeff says there are 215 different ways to choose 1 shrub and 1 rose tree. Could Jeff be correct? And you must show how you get your answer. Now if we knew how many rose trees there were, we would do 17 and we would multiply it by that number. Let's call that number x. So 17 times x, whatever that would be. And that would give us the answer 215 if Jeff is correct here. Now basically all we need to figure out is there a number that you can times 17 by to get 215? And if there is, then obviously Jeff can be correct. If there isn't, then he can't be correct there. It can't be possible. So if we think about this in reverse, then if we just do 215 and divide it by 17, and I'll do that on the calculator, see what we get. 215 divided by 17, and we get a decimal. We get 12.64. and a lot more decimals there, but 12.64. The important thing here is that it's not a whole number. So if it was 12, for example, 17 times 12, that'd give us 204. That could be a possible amount, 204. Or maybe 17 times 13, which would give us 221. So they would both be possible combinations, but this option here of having 215 possible combinations is not correct, so no. Okay, because there is no number that multiplies by 17 to make 215. So just thinking about this in reverse with in terms of the total there, and actually is that a possible total? Let's have a look at one more of these. Okay, so in this question we've got some different options, a lot more words. It says Sadia is going to buy a new car. For the car she can choose 1 body colour, 1 roof colour and 1 wheel type, and she can choose from 19 different body colours and 25 different wheel types. But it doesn't then tell us how many. Which one does it not tell us? It gives us the body colour, it gives us the wheel type, but it doesn't tell us anything about the roof colour. So it says the total number of ways that she can choose these is 3,325. Work out the number of different roof colours that Sadia can choose from. So it doesn't say is it right or wrong. There's definitely going to be 3,325. We just need to figure out then what that number is going to be to actually get there. So at the moment with these two, we've got 19 and 25. So we know that just those we can do 19 times 25. And then we're going to times it by something else. Let's call it x again. And that is going to equal 3,325. So if we work out the 19 times 25 to start with, that gives us 475. So let's just write this down here. So we've got 475 times something is going to equal 3,325. So we just need to figure out what that is, and we can do it in reverse just like before. We can do the 3,325, divide that by 475, and it will tell us what that number is, and this time we should get a whole number, otherwise we've done something wrong. So 3325 divided by 475 gives us the answer 7. There we go, so our answer is 7. So we've got 7, what was it about roof colours? So we can say 7 roof colours. There we go, that she can choose from. And there's our final answer. And just something different here, obviously thinking about it in reverse and making sure that we get that whole number there to figure out what number's missing in our multiplication. Right, okay, so quite nice and simple hopefully. Here's a couple for you to have a go at. Right, okay, so there's 2 questions here. So have a go at these 2, pause the video there, we'll go over the answers in a sec. Right, okay, so this first question says, Tracy's going to choose a main course and a dessert in a restaurant. She can choose from 8 main courses and some desserts. Tracy says there are 52 different ways to choose a main and a dessert. Could Tracy be correct? Well, we've got 8 main courses, and we're going to multiply that by something, and that's got to equal 52. So if we actually go about that in reverse then, so 52 divided by 8, what does that equal? And hopefully you can already spot that without a calculator, that's not going to be a whole number. It comes out as 6.5. So no, Tracy could not be correct, because it would have to be either 6 or 7. We can't have 6.5 desserts, okay? So we could have, just thinking about it logically, 8 times 6 would give us 48, or we could have 8 times 7, which would give us 56. We definitely can't have 52 options there, so there's our final answer for that first one. It would just be no, shown backed up by our working out there. The next one, Amelia is going to choose a new bike. She can choose from 4 different frame sizes, 18 different colours and X different wheel types. The total number of ways she can choose all 3 is 432. Work out the number of different wheel types that Amelia can choose. So we've got 4 different frames, and we're going to multiply that by the 18 different colours, and then we're going to multiply that by this unknown number that we don't have at the moment, but it's going to equal 432. So 4 times 18 at the moment gives us a total of 72. So we've got 72 times something. It's going to equal 432. So again, just thinking about that in reverse, we'll do 432, divide that by 72. We'll see what we get. 432 divided by that gives us the answer 6. There we go. So there's 6 different wheel types. There we go. So 6 wheel types. Right, there we go, and there is our 2 answers for those 2 questions. Right, let's have a look at something else and how this can sort of change with the language now. Okay, so this question says there are 16 teams in a football league. 2 teams are going to be chosen at random to play a match. Work out the number of different matches that could take place. So when it comes to a question like this, we've just got to be a little bit careful, because it says here, work out the number of different matches that could take place. Now obviously we've only got 16 teams. Now if we think about this obviously having something like 3 teams, and let's just think about this in a slightly different way. So if we had 3 teams and they're going to play these football matches, let's just imagine we've got team 1, team 2, team 3. So again we've got team 1, team 2, team 3. There we are. So obviously the actual teams can't play themselves, so 1 against 1 is obviously not going to work, so we'll just cancel out some of these at the moment. 2 against 2 is not going to work, and 3 against 3 doesn't work. Let's have a look at these options that we've got here. So we could have 1 playing 2, we could have 1 playing 3, we could have 2 playing 1 and 2 playing 3, or we could have 3 playing 1 or 3 playing 2. Now obviously these are all the different matches that could take place if we were to pick them in any order, but some of these matches are not different, okay? If we have a look, we've got 1 against 3, which is the same as 3 against 1. So we can't have that, that's not going to be a different match, that's going to be the same match, so we can cancel off one of those. Then let's have a look at the next one, let's go for a different colour. Team 1 against Team 2 is the same as Team 2 against Team 1. So obviously we're going to get rid of one of those, let's get rid of that one. And then we could also have, and let's just see what other I've got 2 against 3 and 3 against 2. And again, one of those is going to be the same, so we're going to need to get rid of one of those as well. So let's get rid of that one. So we've only got this one, 1 against 2, we could have 2 against 3, or we could have 3 against 1. And if we apply the sort of logic here that we did before, look, let's think about what we do. We've got 3 teams. On the second pick, we've only got 2 teams, so we'd do 3 times 2, and that would give us the answer 6. But obviously half of those options were doubled up, so they weren't different matches. They were actually going to be the same match, just in a slightly different order, as they were happening at the same time. Okay, we couldn't have the two different options there. So if we were to divide that, in order to get us to get from 6 to 2, obviously it's half the amount, so all we need to do is divide that by 2, and we get our answer there, which is 3. Okay, so thinking about this, obviously with the language there, when it says the number of different matches that could take place, obviously some of those are actually the same matches, just in a slightly different order. Okay, and we can't have that happening because that's not going to be a different match, it's going to be exactly the same match. It's just in terms of picking one of them first or picking one of them second, but actually that does result in exactly the same match. So actually, if we have a look at this then in terms of our larger amount of teams here, let's just get rid of all of this. And again, we don't want to draw out a big table for 16 teams because that's going to take absolutely ages, but we could do that, and obviously you'd see the same sort of logic being applied there. But when we've got 16 teams, look, all we do is we have 16 teams on the first pick, and then we are going to pick from 15 additional teams. So we've got 16 times 15 to start with, and 16 times 15 gives us a total result of 240 matches. But obviously half of those matches are going to be exactly the same, so they're not going to be different matches, they're going to be the same match, just picked in a different order. So to finish this off, we have to divide it by 2, and 240 divided by 2 gives us 120 matches. There we go. So we've just got this little option here. We've just got to be careful sometimes with the language when it's just talking about something which can actually just be the same but in reverse. Okay, not like our sandwich scenario there, where we can obviously have different options on different days, but this is obviously happening at the same time, so we can't have this same match just in the opposite in reverse. It'd be exactly the same thing. So obviously sometimes we just need to halve the answer here, and we're going to have a look at a couple of these sorts of questions. Okay, so here's our next one. Okay, so we've got this question here. It's very similar to one of the ones that we started on. It says there are 17 men in a choir. The choir is going to sing at a concert. 2 of the men are going to be chosen to make a pair to sing one of the songs. Ben thinks the number of different pairs to be chosen is 136. Mark thinks the number of different pairs that can be chosen is 272. Who is correct, Ben or Mark? Give a reason for your answer. So when we look at this, look, we've got the 17 men in a choir, and it says 2 of them are going to be chosen. Okay, so obviously if we're going to choose 2 of them, and again you can apply the same logic as we did with the football matches. When we actually pick these 2 people, it doesn't matter whether I pick, let's call it, imagine it's man number 1, man number 2, up to 17. If I pick man number 1 and man number 2, that's going to be exactly the same as picking man number 2 and man number 1. It doesn't matter what order they go in, it's not happening on different days, it's happening at the same time. So I can't have 2 different options being the same 2 people. Okay, so this is another option here where we're going to have our final result, because on the first pick we've got 17 men, and on the second pick we're going to have 16 men to choose from, and 17 times 16 gives us our answer 272. Which is where Mark has got his answer there, 272. But obviously we know that we can't have these options being doubled up, because that would be exactly the same. And it does say in the question here, look, different pairs, and that's what we're looking for. How many different pairs are there? So we don't want one of the same pairs obviously being doubled up. So we'll divide that by 2, and if we divide that by 2, we get the answer 136. There we go. So we would say in this question, Ben is correct. Okay, and the reason being is that he hasn't included the doubled up pairs or something like that. Okay, but there we go. That is sort of what we would do here when we're looking for different pairs for something that's happening on the same day from the same sort of selection of people, or it could be selection of cards or something like that. But here we go. Let's have a look at a couple of these questions to have a go at. Right, okay, here we go. So there's 2 questions. So pause the video there, have a go, and we'll go over the answers in a sec. Right, okay, so this first one on the left, it says there are 52 cards in a deck. Tom's going to give 2 cards to Jay. How many different pairs of cards could Jay get? So on the first pick, he's got 52, and on the second pick, he's got 51. There we go. So 52 times 51 is going to give us this quite a large number here, 2,652. But obviously a lot of those options there, if you know your cards well, you could have the ace of hearts and the ace of clubs, let's say, but that would be exactly the same as the ace of clubs and the ace of hearts, okay, just obviously in reverse. And it does say how many different pairs does he get, so we don't want those similar pairs there, so we'll divide this by 2. There we go, and we get the answer 1,326. Right, there we go, and let's highlight that up. And on our next one, there are 30 students in a class. 2 students are going to be selected to receive a prize. How many different pairs? There we go, there's all the language is the same throughout them all. How many different pairs of students could be selected? So again, on the first pick, we've got 30. And then on the second pick, we've got 29. So 30 times 29 gives us 870 different pairs. But obviously, again, that is going to include people being doubled up on these 2 different selections. So we just want to divide that by 2. There we go, and we get 435. There we go. and there is our final option. Right, there we go. So there's quite a few questions. I've got 2 more questions for us to have a look at now. Something a little bit more challenging just in terms of the language and how we might approach it in different ways, but we're going to have a look at some of these questions now. Right, okay, so this question says, in a restaurant there are 9 starters, 15 mains and 8 desserts. Janet is going to choose one of the following combinations for her meal. So she's going to choose either a starter and a main and a starter, I'm going to do this in different colours, or a main and a dessert, sorry. Or her final option is she's going to have a starter, a main and a dessert, so all 3. Show that there are 1,335 different ways to choose the meal. So for this first option then, the starter and the main, let's have a look at that to start with. So for the starter and the main, how can she do that? So there's 9 starters and 15 mains, so that would be 9 times 15. There we go, so 9 times 15, that's how many different ways she has of doing that. And that would be 135 different options. When it comes to the main and the dessert, look, let's have a look at that one second. So there's 15 mains and 8 desserts, so that'd be 15 times 8. And 15 times 8 there gives us 120. And then for this last one, which I'll do over here, we could have a starter, a main and a dessert. So that's going to be all 3, so that'd be 9 times 15 times the 8. There we go. So 9 times 15 times 8 gives us 1,080. There we go. Right, so we've got all these different options. Let's just highlight these up. We've got the 1,080, the 135 and the 120. And obviously it says show that there are 1,335 different ways to choose this meal. Well, she's got all these different options to choose from. So if we combine those all together, we've got 1,080 plus 135 plus the 120. And if we add those all up, let's just double check it's definitely going to answer that. There we go, and that does equal 1,335. There we go, and that's shown there that there is 1,335 different ways of choosing that meal if she's going to use one of those different combinations there. Right, okay, one more question to have a look at before we finish. Okay, so something a little bit different here. We've got 2 different questions. It says there are 3 dials on a combination lock. Each dial can be set to one of the numbers 1, 2, 3, 4 or 5. The 3-digit number 553, which is on the diagram over here, is one way that it can be set. So we can see that there, 553. It says work out the number of different 3-digit numbers that can be set for the combination lock. So it just says different 3-digit numbers. So that can be any amount of numbers on each lock. Let's have a look, different 3-digit numbers. We could have 111, 112. We could have any sort of different combination there. It doesn't say anything about not allowing repeating numbers in each one. So we could have 111, that'd be fine. Okay, obviously not worrying about the fact that there's 553 up there. That's just one of the options that we could have within this. But in terms of the different 3-digit numbers, what could we have? Now part B is slightly different. It says how many of the possible 3-digit numbers have 3 different digits. Okay, so 3 different digits there. And that would mean that we couldn't have 111 anymore. We could only have something with different digits. So 1, 2, 3 would be fine, but 111 would not be allowed because that's got the same digits within it. So 2 different questions there. So what I would say is pause the video, have a go, see what you get for these answers, and we'll go over the answers in a sec. Okay, so this first one, it says work out the number of different 3-digit numbers. So we just need to think about how many options we have on each pick. So on the first pick, we've got 5 different numbers to choose from, so we've got 5 options there. On the second pick, it doesn't matter what we choose, we can choose any of those 5 numbers again, so we've got 5 numbers again. And on the third pick, again, it doesn't matter what number we choose, so we've just got 5 options again. So it's 5 times 5 times 5, and that would give us 125 different options there of different combinations that we can set on this padlock. And there we go, there's our first answer. Now the second one's slightly different. It says how many of the possible 3-digit numbers have 3 different digits. So this means on the first pick, look, we've got 5 options, but on the next pick, let's imagine we've picked a 1, we cannot have a 1 again, so we can have a 2, 3, 4 or 5. So we've only got 4 options to pick from now, so that would be times 4. And then let's imagine we've picked a 1 and a 2. We can no longer have a 1 and a 2, so we can only pick a 3, 4 or 5. So we've only got 3 options now on that third pick, so that would be 3 options. So 5 times 4 times 3 gives us a total of 60 options if we want to make sure we have all different digits there. Right, there we go, and that is our final answer on this last question. So that is just an overview of all the different kinds of questions that you could have on the product rule for counting. So hopefully you found that useful. If you did, if it was helpful, please like, please comment, please subscribe, and I'll see you for the next one.